Okay, so now we're going to look at more complex types of polynomials. And before we can do that, we're going to have to talk about factors of polynomials. So when we're dealing with complex polynomials, we're looking at polynomials that have multiple variables in a term. So one we need to address what the factor of a monomial, or just kind of one term, is. So factors of a monomial are all the individual numbers or variables that are being multiplied together to create the term. So for example, this is just one term, and this kind of looks like the ones we've already been working with, a term with a variable and a number out in front. So what's being multiplied together, remember this is multiplication, keeping them together, are 4 and x squared. So those are the two factors being multiplied to make that individual term. So then if we look at something called a complex term, right? These are complex because they have multiple variables and numbers. So this is all still one term, and we're just going to break it apart into all the individual factors making up that term. So 7 is making up that term, x is making up that term, y squared is making that term, and z to the 6th is also making up that term. Okay? So I'm going to do one more and then try one on your own. So this one right here, this is a complex term. So all of the factors making up this individual term are 3, x to the 3rd, and y. So 3 factors making up the one term. So go ahead and try this one on your own. Pause the video, try it on your own. I'm going to go ahead and do it. So when you finish, start the video again. So this one, we have a couple individual factors. We have 10, x to the 6th, y, and z to the 3rd. So we will save this one for class to review. So classifying polynomials by complex degrees. So because these are complex terms, right, there's more than one variable, that means they also have complex degrees. So remember, degrees we learned were the value of the exponent of a term. But if we look at all of these have multiple exponents making up one term. So that's what we're going to talk about now. So when a term of a polynomial has more than one variable, we need to add the exponents to determine the degree. Exponents. Ooh, messed that spelling up. Exponents. So if I look at this one right here, this is one term, but it has multiple exponents making up that term. So the first exponent is 2, the next exponent is 3, so 2 plus 3 is 5, so this is a 5th degree term. So looking here, this is where it gets tricky. We have 3 variables making up this term. We have x, and what we have to remember, this x is technically to the first, so I'm going to pencil in a 1 to remind myself. So I have the first, the second, and the 6th, all making up one term. So the total degree of this term, 1 plus 2 plus 6, that is going to be to the 9th degree. So I'll do one more. Here we have r to the 3rd, so a 3rd degree. We have t to the 5th, so a 5th degree. So altogether, this one term is to the 8th degree. So go ahead and pause the video and try 8 on your own, and then you can restart it again, and then I'll go over it. So pause the video, try 8 on your own. Okay, so this one, again, we have some complex stuff going on, right? We have a 6, we have a z, and we have to remember that is technically to the first. So we also have a 1, and then we have a 3. So 6 plus 1 plus 3 is the 10th degree. So we're going to save these 2 for class as review. Now, putting it all together, we're still going to talk about the same stuff, putting something in standard form, talking about the degree, classifying by all of this stuff here. So first things first, when I want to put this in standard form, because this is a complex polynomial, I need to figure out the degree of each term. Because remember, standard form is the largest exponential value to the smallest. So if I look here, this term has a 1 and a 2. So kind of like we did up here, right? This one term is technically to the 3rd, 1 and 2. This term right here has a 3, and a 1. So 3, 6, 7. This whole term right here is to the 7th degree. which means this term right here has a larger exponential value. So when putting in standard form, I need to put the largest value first. So this negative 5x cubed y cubed z is going to be the first term. And then the second term is going to be 8xy squared. Now, this is in standard form, largest exponent to the smallest. Now I need to classify by degree. In the process of putting this in standard form, we found out the total degree of each one. So the largest degree here is to the 7th. So this is a 7th degree. And then there are only 2 terms. So remember, terms are broken up by the addition sign. So 1 term here, this is the second term. So 2 terms, if you need a reference, remember we did this earlier, 2 terms is a binomial. So this is a binomial, right? And then we have coefficients that we're looking at. Coefficients are the front number. So this front number is a negative 5. This front number is an 8, so the numbers in front of variables. And then this last one, leading coefficient, it's leading from when we're in standard form. So we are in standard form here. This is the leading coefficient of negative 5. Okay, so I'm going to do one more, and then we'll save the remaining 2 for class. I'm not going to have you try one of these on your own. They're a little bit harder. You can try this one on your own if you want. You can pause it, but I'm just going to go through it, and we'll save 13 and 14 for class. So standard form. This first term only has 1 variable, so it's just to the 3rd. This term has 2 for a total of 6. So this is the larger exponential value, which means this one needs to go to the front, and the 7x cubed needs to go to the back. Now, this is already, we figured out the degree of each term, so the largest degree is 6. And this is a binomial because there are 2 terms. So bi means 2, binomial. The coefficients are whatever number is in front of the variable. So I have a 5 and I have a 7. And the leading coefficient is the leading coefficient when in standard form. So that would be a 5. So we're going to leave these 2 to do in class.